little dark for that.
You can't get time. You want to just leave it downstairs?
Yeah, you can.
Okay.
Didn't get. I think this was the best way how I had it.
And
It's just a little dark.
you want to turn on the overhead light?
No. No, that's not gonna work.
All right. Good luck.
Oh, you know what? I know what I need to do.
Need anything else?
Let's see if that works. I feel like it still looks so dark. That looks better. There we go. It's the top of it. I need to test that out. How else do I welcome? Kimberly testing. It looks like somebody else joined us too. How is the lighting here? Does it look good? Can you hear me? All right. Well, I'm going to give people, thank you for joining us. Oh. Okay, I see I have a little problem. It's backwards to me. Let me do a quick switch here because I can't write backwards. Alrighty, I think that might be a little bit better for me so that I can write not upside down. Alrighty. Hello, Tiki Williams. This is my mom's account. It's Josh. Nice to meet you. We did get your problem, and you're actually gonna be the first one we're gonna work out tonight. So let's get right into it. I'm gonna leave it up here as we get started. It says a father and son went to the lake. The father caught 2 and 3/4 pounds, of fish. The son caught 2½ times as much fish as his father caught. So let me ask the question to our audience. It says times. So what is that operation that we're going to do? What do we think when we hear times? I'll give you guys a minute to maybe drop it in the chat. We're going to multiply. You're absolutely correct. And I'm just going to put an X here to stand for I'm going to multiply something. Okay? And so it wants to know which choice is correct here. So we can actually work this in two ways. And I'm going to show you both just so we can get our thinking around how we can do problems multiple ways, that there's not a one size fit all. So it says dad had 2 3/4. So let's make that a picture, 2 3/4. And since it said he had 2 times, we know that 2 times as many would be just 2 circles more. So we could absolutely do this visually and add these together because we know that multiplication and addition go together. So let's see how we can do that. So we have 2, 2, and 2 for our whole number is 6. Then when we add fractions, we keep the same denominator, correct? And we're just going to add our numerator. So 3 plus 3 is 6, plus 3 is 9. And then we notice something here with 9/4. Is that number improper? It is. So that means we have to reduce this down. So we're really asking ourselves, how many 4s are in that 9? And we know that there are 2 4s in that 9. All righty. So let's subtract 4 out of there. 9 minus 4, we get 5/4, and then we can subtract the 4 again. We get a 1/4. And so we will get some holes. So I want to show this how we would actually do it by multiplying. So I'm going to switch it up a little bit. So let's do it with multiplication. And that's probably the best way to show it to make sure we get everything right. So we have 2 3/4, and we have times 2 1/2. So I like to use a method called Texas method. Let me take that back. It's called the Texas. So we're going to put the T and the X. And the T stands for we're going to add, and the X stands for we're going to multiply. And when we are going from a mixed number to an improper fraction, this is the strategy we want to use. So we are going to do 2 times 4, which gives us 8, plus 3 gives us an 11. And then we always keep our denominator the same, so it's going to be 4. And then we're going to multiply it by, same thing, Texas first. So we'll do 2 times 2, which will be 4, plus 1 gives us 5, and then that will be over 2. So really we are putting it over 2, and that was just kind of some scratch work I did here for you. So now we have 11/4 times 5 over 2. And when we multiply fractions, we multiply straight across. So 11 times 5 is 55, and 4 times 2 is 8. So now we have 55 over 8, which we already know is an improper fraction. And how can we go from an improper fraction back to the mixed numbers that we had? I'll give anybody a second to drop it in the chat. What operation can we do to get this back? Divide. Thank you. You are correct. So we are going to divide. And now we're going to ask ourselves, What times 8 gets us really, 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 really close to 55? And that will be 8 times 6, which is 48. And we are going to subtract. And that will leave us 7. And this remainder here, this actually goes back over our fraction of 7/8. So we get 6 and 7 over 8, which is our answer B. And Jessica, correct. The fraction bar means to divide. Thank you for that. And whenever you have a remainder, it is actually a fractional part. That is why we can put it back over our denominator of 8, and our answer is 6 and 7/8. So I hope that helped you, Jace. And you had one other problem here. Jace, I'll let you type. Did you get all the work here before I move on? I want to make sure you got it. Okay. All right. So let's roll on over to problem 2. All right. Problem 2 says Kia loves to roller skate. On Saturday, she skated 3 2/3 hours. On Sunday, she skated 6 1/2 hours. How many more hours did she skate on Sunday? So our key word here is how many more. And how many more tells us that we are going to subtract. Okay? So what are we subtracting? How many more hours did she skate on Sunday? So our Sunday was 6.5. And on Saturday, so minus, she skated 3 2/3. Well, it's really hard, right? To subtract these mixed numbers. They don't look alike. We have nothing in common because we know with fractions, those denominators have to be the same for us to do anything. So we need to use that Texas method again to first change them to improper fractions. So we will do 6 times 2, which is 12, plus 1 is 13. And we keep our denominator the same, so we'll put it over 2. And then minus, and we're going to do the same here, plus. So 3 times 3 is 9, plus 2 is 11. And we're going to put it over 3. So can we subtract it yet? Nope. We still have to find our common denominators now. We got them in a form that we can do, but we want to have the same denominators. And so a quick way I like to find common denominators is just multiplying these two numbers by each other. So 2 times 3 is 6. And what we do to the bottom, we do to the top. So that means we're going to do 3 times 13. And it's okay if you need to come to the side real quick. So that's 39 minus, and then 2 times 11, we know is 22. And so now we are going to subtract 39 minus 22. We get 17. So we get 17 over 6, but that's still an improper fraction, right? So we need to change it back to a mixed number like our answer choices. And so like we did the last time, we are going to divide. So 6 divided into 17. What multiplies by 6 that gets us really close to 17? It will be 2, which is 12. And we have our remainder of 5, which we will put back over our fraction. So we get 2 and 5 over 6, which is our answer choice C. All righty. And let me move my paper. Jace, did you get all of that? And I hope you understood as well. Let us know in the chat if you got that. And then we are going to move to our next problem. Yes, ma'am. This helped me very much. Well, we are so glad to hear. And make sure to always join us on Wednesdays. We will be working out problems. We really appreciate you emailing us. Alrighty, so we had an algebra student that sent us an email, and right now they are working on literal equations. So that is up next. And we are going to work out a quick one here. They sent a lot, so I'm just going to choose a couple. Let's see. So our first one is that D equals RT. And they're called literal equations because we have no numbers. It is just the alphabet, okay? And what this one asks us, it wants us to solve for R. So that means that we are isolating this R by itself, and it actually wants to know what will this equation be if we were solving for R. So if we really did have numbers and we were like, what is R going to be? What do we put it in as first? So we know, just like we solve regular equations, we first need to decide what's all happening to R. Well, T is multiplying by R. When they're next to each other, that means they're multiplying. So to get R by itself, we have to do the opposite. So we're going to divide both sides by T. So our answer would actually be R equals D over T. And that is how you solve a literal equation. So I'm going to pick another harder one because I wanted to start off easy and work our way up, since they have quite a few problems on here for sure. So let's do, this one is spicy. Okay, we're going to do this one. As you can tell, I'm totally a math enthusiast. So yes, I did say spicy. Okay, so we have that E is divided by little e is equal to R plus R over R. And it wants us to solve for little e. Okay, this looks kind of intimidating when you see it, right? But again, we're just solving for little e. We want to leave it all by itself. And there's always multiple ways that you can work this for sure. But we are going to work it like this. So when something is divided by a number, we can do the reciprocal of it. And the reciprocal helps it to equal 1. So the reciprocal of this big E would be having 1 over E, because that's like the E dividing. And so I want to show you how that works, because what we do to one side, we do to the other. When we're technically multiplying. So that will be big E over big E, and it will leave our little e like this. Okay? Even though I could have flipped that. Actually, yeah. But we'll do it like this and then I'll flip it. So that gives us big R plus R over R times E. Okay? And so then that leaves us 1 over E is equal to that. And really, we want just E. So instead, we are going to flip this E. And so that means we're going to flip this side too, because what we do to one side, we do to the other. And that's what gave us E by itself. And just for your knowledge, there's always an imaginary 1 under every number, even 1, 2, it doesn't matter. That E, there's an actual invisible 1 there, but we just write it as E. So that would be our literal equation for this one. It would be that E equals ER over R plus R. Oh, I'm sorry. Can't see. All righty. Would y'all like me to work one more of the literal equations, or would you like to see something else that we got? I'll wait for you all in the chat. Let's do one more. All right, let's do one more. Let's see which is another good one. Oh, this is a good one. This is a good one. Okay, so we are going to do A equals H parentheses B1 plus B2 divided by 2. And we are solving for B2. All right. And Kaden requested a problem in the chat. Kaden, we will absolutely do a 4th grade division problem after this for you. Stay tuned. All right. Thank you. I really appreciate your request. All right. So we want to solve for B2. So we want to get this by itself, but it's a lot going on first, right? So we are going to take this thing one step at a time so that we can get this isolated. So we know that this 2 is dividing and this H is multiplying by it. So we can actually move that at one time. So let's do 2 over H and 2 over H on this side. Because on this side, it cancels because it's top and bottom. So we would be left with 2A over H on this side is equal to B1 plus B2. And since they're by themselves and the H isn't multiplying, we can go ahead and drop our parentheses. So now we have B1 plus B2, and we can get that B2 by itself. So B1 here is adding, so let's subtract B1 from both sides. So B1. So we get that 2A over H, let me move that up for you all, minus B1 is equal to B2. That would be our answer. And you can write it either direction. It means the same thing, for sure. All righty. Now let's jump right into Caden's division problem. I'm going to pick another color. All righty. 523 divided by 6. Okay. So I like this acronym to help me. McDonald's doesn't sell cheeseburgers raw. And I like this acronym because, one, it helps me keep pace of my steps and it makes sure that we don't miss anything. So I'm just going to write those letters off to the side. McDonald's doesn't serve cheeseburgers raw. And what it stands for is we're going to multiply first, then we're going to divide, we're going to subtract, we're going to check our work, we're going to bring down, and then we're either going to repeat or that will be our remainder. And I know remainder is just not going to be on there really, but that's okay. Thank you so much in the chat. All righty. So first it says we're going to multiply. So what can we multiply to give us 5? What times 5? What can we multiply by 6 to give us 5? Nothing, right? So we're going to just go ahead and skip to our 52. So what can we multiply by 6 that gets us really, really close to 52? Okay, Jace, you're right. We could put a 0 there, but I'm just not even going to put my 0. I'm going to let it be 8. Great job. So 6 times 8 is 48. And then that is where, so we're going to subtract next. So we get 12 minus 8 is 4. And then we're going to check that we did all of that correct. We did. Now we're going to bring down. So we're going to bring down that 3. So we repeat. What times 6 gets us really close to 43 this time? Anybody in the chat? All righty. Okay, somebody said their teacher showed them the McDonald's trick too. Awesome. All right, 6 times 7. And we know 6 times 7 is 42. And so we are going to now subtract, which gives us 1. We're going to check our work. That looks good. And now, because we have nothing left, this will be our remainder. So 87 remainder 1 would be our answer. Awesome. Thank you so much, Kaden, for that problem. And McDonald's is such a great method that you can always use to make sure that you're doing your steps correctly as you go. Can you show us using the box method? Absolutely. Okay, so we are just going to kick it up a notch tonight, aren't we? Okay, let's see. So we want to see this using the box method. And so using the box method is still like the regular way, except for instead of bringing stuff down, we bring stuff up. That's the biggest difference when we do the box method. So we're going to use the same problem since we all already know it, just to show it. Oh, somebody says this is their favorite method. Okay. So we're really using those same McDonald's steps, right? I'm going to just post them to remind you. So can anything go in our 5? Nope. So this time we're subtracting by 0, which gives us 5, and then we're going to bring it up instead. So now 52 is in that box. So now we're saying what times 6 gets us really close to 52, and that's still 8. And then we're going to subtract in our box. And so 12 minus 8 gives us 4, and we're going to bring that 4 up. So now in this box, what number times 6 gets us close to 43? Well, we know that would be 7. So that will be 42, and we're going to subtract. And that gives us 1. And since there's nothing to bring up, that will give us a remainder 1. So that is how we use the box method. It just really helps us organize, and you don't have to think about, oh, I got to bring this number down, or what place value does it change to, because we are using a box to solve it. So that's the advantage of using the box method. There's a few steps that you don't have to do to make sure that your place value is correct. All righty. So we are just on a roll tonight. I wanted to also do something for my Algebra 2 students. We had an absolute value problem that we were going to do. So we're going to go higher on you all tonight. We're headed to absolute value equations. So I have that x plus 4 minus 3 is equal to 5. And we want to solve this problem. And I know we still have some younger babies on here, but this is just a great time to see what you might get exposed to. And I'm definitely going to head on back down to some 5th and 2nd grade problems after we do a couple of these as well. So when we are solving, this is considered an absolute value sign in case you're not familiar. We want to solve and isolate that absolute value because we want to know when we're doing these equations, our goal is always to find that variable. And our variable this time is x. So what is x equal? What do we have? So we want to isolate that. That's our first step. So what's happening to the absolute value? It's subtracting by 3. So the first thing we want to do is add 3 to both sides. That's just our very first step. So we're going to get 8. This cancels out to 0. And we are left with x plus 4, or the absolute value of x plus 4. And how do we remove that absolute value sign so that we can actually work with x? Well, we are going to break that absolute value apart, and it creates 2 equations for us. It is going to create x plus 4 is equal to a positive 8. And it's also going to create, and I'm going to switch colors, x plus 4 is equal to a negative 8 because we can get a negative and a positive value by breaking up that absolute value. So just like we always said at the beginning, we want to solve for x. And so we're going to do that for each of our problems. So this is x plus 4 equals 8. So we're going to subtract by 4 on both sides. So x is going to equal 4 for this side. And then on this side, we are going to subtract by 4 as well. And x is going to equal a negative 12. So our problem here, x has 2 solutions. It is 4 comma negative 12. Alrighty, and you can check this by putting 4 inside and seeing if those are correct. So 4 plus 4 we know is 8, and when we take the absolute value, positive 8 comes out. When we subtract by 3, it gives us 5. We can do negative 12 plus 4, which would give us a negative 8, and because it's in the absolute value sign, it will come out as a positive 8. So then we will get again 8 minus 3, which gives us 5. All righty. It looks like we have a few others that have joined us tonight. If you have any problems that you would like to see work, feel free. We've done some algebra. We did some division. We've done some 6th grade math tonight. We're just chugging along, and we have plenty more problems to do. I'm going to see what, we got some paper here. Don't mind me. Alrighty, so what is our next problem gonna be tonight? Okay, I got this problem from a student's review, and I thought it would be a really good one for us to do. It is a model, and I'm gonna redraw it. Hopefully, I can draw it pretty decently. Now, don't talk about my drawing. Don't talk about my drawing. I tried my best here. All righty. So the question asks, which expression is represented by the area model? And so for area, I tell my students it's always what's on the inside. So imagine these being like little blocks. We want to know how much is that on the inside. Well, for area, we know we are multiplying. So it's like us multiplying this 5 and 10 here. So we know the area of this would be 50. But it wants to know what is our expression that gives us this. Well, what we could do, and actually this is supposed to be a 3, but that's okay. What we can do, since we have these on both sides, the expression would be 15 times 15 is equal to whatever our area is. Now, how you can actually use the model to solve for that. So we added both sides, and that's how you see we get 15 and 15. But actually using the model, we know 5 times 10 is 50, and then it would be 5 times 5 is 25. 10 times 10 is 100. 10 times 5 is 50. And then what we can do, we can add these all together. And I'll do it over here. 50 plus 100 plus 25 plus 50. So we get a 5. That's 12. So 15 times 15 is 225. So even if you don't want to multiply 15 times 15, you could always draw an area model. And that area model is using place value, right? Because our 10s, right there, our 1s, right there. Anytime you can absolutely do this. All right, we have an order of operations request as well. All righty, so we are going to jump right into an order of operations problem as requested. And nowadays, we have multiple ways that we can do order of operations. We can use PEMDAS, we can use GEMDAS, and PEMDAS stands for parentheses, whereas GEMDAS stands for groupings. So it's just really making sure that you include all of your brackets and things like that. Alrighty, so we are going to go with 3 plus 6 parentheses 11 plus 1 minus 4 parentheses bracket divided by 8 times 2. Yeah, it looks like a little doozy here, but we are going to just jump right in. And first, like we said, we are going to use GEMDAS. So I'm going to write it to the side. GEMDAS. And that G stands for groupings now. This is a very interesting problem. It is really going to allow us to see GEMDAS or PEMDAS in its whole fashion here. So I wanted to make sure that we had a really solid example. So we are going to we're first going to do what's in our inside parentheses because you work inside, then you come out, okay? So we're going to do our 11 plus 1 is 12, and 12 minus 4 is 8. And then so now we will just put that 6 on the outside of it, and you can keep your brackets, and we just rewrite our other parts. So 3 plus, and then divided by 8 times 2. So now we're still at our G, our groupings. So now we're going to do 6 times 8, which is 48. And we're going to bring down the things that we haven't touched yet. All righty. Now that we are out of there, we're going to go to E exponents, but we don't have any. So now we are multiplying and dividing. So we do have division here. And we know that multiplying and dividing, they're on the same level. So we work left to right. So we are going to divide that 48 divided by 8, excuse me. So we're going to leave our 3 plus. What times 8 gives me 48? That is 6 times 2. Now, we're still multiplying and dividing. That multiplication was to our right. So 6 times 2 is 12. And we're going to still bring down our 3. And the last is addition and subtraction. And we just have addition. So 3 plus 12 is 15. Yes, multiplication and division are the same, and addition and subtraction are the same, and we always have to work them left to right. Sometimes my teacher used to make us, write it real small, like L to R, just so that you remember that they are on the same playing field, and you just have to pay attention to where they are in your order of operations problem, for sure. All righty, we are just really on a roll tonight. Does anybody else have any requests? I will do one more order of operations before we move on to another topic. All righty, let's do... Okay, let's do this one. 8 squared times 2 minus 14 minus 12 equals. So I always like to write my strategy. I'm a big strategy kind of person. Whenever there is one, I will use it. So we're going to write our GEMDAS. This time we don't have any groupings, so we're not going to start there. But we do have exponents. We have 8 squared. So 8 squared is 64 because it's really 8 times 8, just so that you know. So we get 64 times 2 minus 14 minus 12 equals. All right, that's what we're looking for. So now we are at multiplying and division. We only have multiplication here. So we are going to do 64 times 2. So 4 times 2 is 8. 2 times 6 is 12. So we will get 128. And then we rewrite our minus 14 minus 12. And again, we are back to addition and subtraction. And this time we have both subtraction. So we're just going to start left to right. 128 minus 14. We're thinking about our ones place. So 8 minus 4 leaves us with a 4, 1, and 1. And then we're going to subtract by 12. Same thing, 4 minus 2 gives us 2. 1 minus 1 gives us 0. So 102 would be our answer. All righty, let's go to... I did have someone submit some word problems as well. So I'm going to try to do, and it's a second grader, 2-step adding and subtracting word problem. I'm going to write it out for us really, really quickly, and we will just work it together as we go. Let's go with our blue. Mia bought a box of 73 markers. All right, Mia bought a box of 73 markers. She lost 12 of them. Her father bought her 15 more. How many markers does Mia have now? All righty. So it's how many does she have now? And I'm going to try to adjust that. So she bought a box, and we're going to underline with 73 markers. She lost. So if we lost something, that means we're going to subtract. I'm just going to put a reminder there for myself. And her father bought her 15 more. So then we are going to add, because this is a two-step problem. So let's first do 73 minus 12. And so we know 3 minus 2 is 1. 7 minus 1 is 6. And then now we are going to add 15. 1 plus 5 is 6. 6 plus 1 is 7. So she now has 76 markers. We really, when we're working out the problems, no matter what grade level you are, we really want to make sure that we're always underlining our key words and making sure that we have a clear understanding of what is this problem asking me. A lot of the times we think math and reading don't necessarily go together, but there is literacy in math. So we want to really be sure that we use our context clues and all those same kind of strategies you use in your reading class, that we use those with our word problems, no matter what grade you're in, for sure. Let's see what is up next, or that was submitted to us that we can share. Okay, so this problem was submitted to us. Let me see if I can get it down for y'all real quick. So this one is a 4th grade problem. Which of the following statements is not true? And we know during test taking time, especially, they really like to use the word not. So we always want to make sure that we are solving for the correct thing when we are doing these kinds of problems. And so we are going to use our place value to compare some numbers to see which statement is not true in one moment. Alrighty, so I'll just slide it on top here. Which of the following statements is not true? So we are comparing. Yes, thank you from our audience saying that the new 2.0 questions here in Texas, they ask which 2 answers are correct. So we got to really make sure that we read, and how reading is so critical, because we might find that one answer and we were really supposed to put 2 answers. And so you'll only get that partial credit. So for this one here, we want to know which statement is not true. So we're going to be keeping that in mind, that all the ones that are true here, that's not the right answer. So we're going to be looking at our place value. So we want to start at the beginning. We have 11,000. We have 11,000 here. We have a 2 in our hundreds place. We have a 2 in our hundreds place here. It is not till we get our tens that we can actually compare. So we have a 1 in our tens on this 11,210, and we have a 0 in our tens for 11,201. So this is correct. 11,210 is greater than 11,201. So this is true. So that is not our answer. Then we have 40,343. And I like to do the same way, comparing my place value the entire time. So we have 40 and 40. Oh, already in our hundreds place, there's a difference. We have a 343, which is less than 433. So this one is true as well. Alrighty. We have 62,201 is greater than 62,021. So let's see. We have 62 and 62. And we see right here at our hundreds places where we have our first difference. And yes, 200 is greater than no hundred. So we have 21. So this statement is true as well. So it means let me hopefully I wrote this problem down, right? That our last answer must be our answer, but we are going to take a look at it. So we have 21,100. Well, we have 201,001. We're already bigger because this does not even have a 2 in the hundred thousandths place. So it was saying that 21,100 is bigger than 201,001. So this is false. So our answer would be D. All righty. Do we have any more questions in the audience? Yes, you're correct. We always have to start comparing with the largest place value. Start with your largest and work your way down to comparing where you first see the difference in your smaller numbers. All righty. I think, do you do these sessions every Wednesday? That is such a great question, Jace. We are going to start doing these sessions every Wednesday, and we might throw in a couple pop-in sessions here or there. We just want to see if everybody finds them helpful. And if you do, then yeah, come on, shoot us an email and we will be here. We'll be doing it as long as you all find value. Oh, you're absolutely welcome. We absolutely love math here at Math-A-Matics Tutoring. This is our passion, our purpose, and I love for students to understand. And that's just our motto is for students to catch up, keep up, and get ahead. And that's what we're really about. So I hope that not only did I solve your problem tonight, but you actually understood and even gained that strategy tonight for sure. And yes, share with your friends. Tell them to come on. Somebody's working their problems for free 99 on Wednesdays. Bring them on over here. We will be happy to support. I'm trying to decide if we're going to do one more, before we wrap up for the evening, oh, we might not be. My computer is about to die. And thank you all for your patience with me. This is definitely something new. So I'm getting used to my setup and everything like that. But we're going to get it as we do this on Wednesdays for sure. Oh, I love that. Even your mom said she learned something tonight. Oh, that's awesome. I love that. Oh, yes. Well, if anybody has any other questions, let us know. And like we said before, we will be doing these on Wednesdays. I hate to rush you off, but my computer is literally about to die on us and I can't plug it in. So this will be all, and we will see you for our next Work It Out Wednesday. Invite somebody, and we truly appreciate you being here with us tonight. Thank you so much.